Welcome! This is Raina Fitzgerald, and in this lesson we're going to look at the slope of a line. Here we have a line in red, and it's positioned on our Cartesian coordinate system, our x-axis and our y-axis. And what we want to do here is we want to look at the slope of the line. So let me write the word slope. The slope of a line, when we talk about the slope of the line, we use the letter m. And when we're describing what m is, we're saying starting at any point on the line, if we start anywhere on the line, how much must we rise up and how much must we run to get to another point on the line. So oftentimes you'll hear that the slope is the rise over the run. So when you think about rise over run, the rise can be rise up in the positive direction or rise down in the negative direction. And your run can be run to the right in the positive direction or run to the left in the negative direction. So we're going to take a look at the slope of this line. Let me write up here, m is the slope of the line that we're looking at. And when we talk about the rise, we're actually talking about our change, delta, y. That triangle means delta, and delta means change. If I start at a certain point, and I'm going to start here at this point, I'm putting a dot here, and this point is when x is -1, y is 0, and I'm going to end at this point that I can see, which is when x is 0, y is 2. So given those 2 points, going back to our slope, m, is the change in y. How does y change from one starting point to another? And that is divided by the change in x. How does x change? Now if we look at these points, let's take our first point right here. I'm going to circle it. And let's say that this is point A. And I'm going to put an A underneath here to represent our point A that I just circled. Okay, and then this is our point B at 0, 2. So I'll mark that with a B. And so A is the point -1, 0, and B is the point 0, 2. Now if we start at point A and we want to know how much do we go up in the y direction, and that is going to be divided by how much we go over in the x direction, we're going to have our slope right here. So if we want to know how much do we rise, then we're going to take the y value for where we want to end up, b, and subtract it from the y value from where we started, a. That's our delta y, and that is going to be divided by, and actually that top bit is this distance right here that I'm pointing at. The distance right here is going to be our y height for b, which is 2, minus the y height for a, which is 0. Now, if we want to find the distance that we go horizontally, our delta x, which is our run, we want to take the difference between our x values. Our x value for point B minus the x value for point A. So let's put those in. The y value for point B is a 2. So we'll put a 2 in. And we want to subtract the y value for point A, which is a 0. That's divided by the x value for point B, which is 0, minus the x value for point A, which is a -1. Now remember, when we are working with algebra, we add the opposite. So this would be plus a negative 0, which is just a 0. But down below in the denominator, it's plus, not a negative, but a positive. And so what we end up on the top is 2 plus 0, which is 2. And in the denominator, 0 plus 1, which is 1. So our slope is 2. Or we could think of it as up 2 over 1. Up 2 units over 1 unit. And I want to point out that if we wanted, we could have found our slope, m, by taking our delta y, and instead of subtracting y sub b minus y sub a, we could have subtracted y sub a minus y sub b. Now the order doesn't matter when you're subtracting your y components, but when you're subtracting your x components, they must be in the same order. So if you're subtracting your x or y component a minus b, then both in the numerator and denominator it must be y sub a minus y sub b in the numerator and x sub a minus x sub b in the denominator. This a b order must match as this b a order matches. So let's finish this one off. If we do it this way, our y sub a, the y for the a value, is 0. So we put a 0 in and we say 0 minus, and the y for the b value, here's b, b's y is 2, so it's 0 minus 2 over, and in the denominator we are going to have our x sub a, and our x sub a is negative 1, and it's going to be negative 1 minus the x sub b. Here's b, x sub b is 0. Again, we want to change our subtraction to add the opposite. So in the numerator, we're going to have plus a negative 2. In the denominator, plus a negative 0. Well, 0 can be positive or negative. It actually has no sign. So what we end up with here is, let me change that color to black. We end up with a negative 2 in the numerator over a negative 2 in the denominator. And a negative 2 over a negative 2 is a positive 2. And as you would expect, both of these slopes are the same, 2, 2, because we're talking about the same line. And so what it's telling us is the first slope, 2 over 1, says we go up in the positive direction 2 units, and then horizontally in the positive direction 1 unit. That's 2 over 1, 2 over 1, 2. Or if it's negative 2 over negative 1, because we started with point A, we went from point A to point B, we are now going to start at point B here, and we're going to go from point B negative 2 units, so we're going to go down 2 units, and then we're going to go horizontally negative 1 unit, and we end up back at another point on our line. So both negative 2 over negative 1, down 2 to the left 1, is going to give us the same slope as 2 over 1, which is up 2 to the right 1. So this is how we relate a slope to a line on the Cartesian coordinate system. Here we're going to look at parallel lines and perpendicular lines. If I have two lines, and actually let me go ahead and I'll draw a line right here, and we'll call this line 1. And I'm going to draw line 1 on the other graph. I'm going to try to draw pretty much the same line. This is freehand, so it's not perfect. And we'll say that this is an L line, also line 1. So I've got two representations of line 1. Now in blue I'm going to draw line 2. Line 2 is going to be parallel to line 1. Here's my line 2. And now I'm going to draw line 3. Line 3 is going to be perpendicular to line 1. So this is line 3. Perpendicular means forming a 90-degree angle. So let's write this down. On the left, we have line 1 is parallel to line 2, and that's mathematically how we would write it. On the right, we have line 1, and it's perpendicular to line 3. In other words, they form an angle, I'll draw the angle here, of 90 degrees. The point where they intersect forms an angle of 90 degrees. Now, in the first case, or the case to the left here, with line 1 and line 2 being parallel, well, line 1 and line 2 both have a slope. Line 1 has a slope 1, and line 2, we'll say, has a slope 2. If, in fact, line 1 and line 2 are parallel, that means that their slopes are the same. They're equal. In our second case over here, where line 1 and line 3 are perpendicular, in this case, line 1, or the slope of line 1, is equal to a negative reciprocal of the slope of line 3. So let's use some real numbers here. I'm going to change my font size down a little bit smaller. We'll go with black. And let's just say that the slope of line 1 is, we'll say it's up 2 over 1. Not exactly, but we'll say that's about what it is. It's 2 over 1. Well, that means that the slope of line 2 is also up 2 over 1. And then over here on the right-hand side, here we have the slope of line 1 is up 2 over 1. And since line 3 is perpendicular, then we can say that the slope of line 3, because the slope of line 1, is positive, the slope of line 3 is going to be negative. And because it's not only the additive inverse, but also the reciprocal, so the 2 over 1 becomes 1 over 2. So what's going on here is when the lines are perpendicular, we look at the slope of one line, positive 2 over 1, and the slope of the other line that is perpendicular to it will be an opposite sign. So the first slope was positive, the perpendicular slope is negative. The first slope was 2 over 1, so the perpendicular slope is the reciprocal 1 over 2. And I want to add that the symbol we use in math to show that lines are parallel is we put a little arrow, just like this, on both lines, and that indicates that these two lines are parallel to each other. Here, we're looking at the slopes of horizontal and vertical lines. Let's start with drawing a horizontal line. This horizontal line goes through the y-axis at -2. So the equation for this line is y is equal to -2. On the right, I'm going to draw a vertical line in blue. This vertical line goes through the x-axis at 2. So the equation for this line is x is equal to 2. If we look at the slope for the red line, we're looking at the rise, the change in y, over the run, which is the change in x. The rise will be 0 because it never rises up or down. The run could be any value. Let's say we run 2 units. 0 divided by any value is 0, which means that the slope for a horizontal line is always 0. Here on the right, when we look for our slope for the blue line, which is the rise, the change in y, over the run, the change in x, we can see that the rise is any number. We can move up so many units. Maybe we're rise up 3 units, but the run will be 0 because we never move horizontally. This creates a divide by 0 error, which means that the slope is undefined. So when we're talking about a vertical line, the slope is undefined. And a horizontal line always has a slope of 0.